Okay, so chemical energetic exercise 2, question 4. What is the bond energy for nitrogen-nitrogen? So you need the energy, the bond energy for nitrogen and nitrogen. Reactant side is a bond breaking side, and the product side is a bond forming side. And that the energy release or energy change is minus 95. So bond breaking energy, the bond breaking side, on the left hand side I'm mentioning bond breaking. So which bond we are breaking? We are breaking 4 nitrogen and hydrogen bonds, NH bonds. 1, 2, 3, and 4. So we are breaking 4 nitrogen and hydrogen bonds, plus we are breaking 1 nitrogen-nitrogen bond. So 4 nitrogen and hydrogen bond energy is 391. So 4 multiplied by 391, and nitrogen-nitrogen bond energy we don't know. That's a question only that we have to find. So this one is X or unknown. Nitrogen-nitrogen bond energy is unknown or X. 4 multiplied by 391. What's the answer? 4 multiplied by 391.
1564.
1564 plus X. So bond breaking energy is 1564 plus X. Why plus X? Because nitrogen hydrogen bond energy we know, but we don't know the nitrogen nitrogen bond energy. Then bond forming side, I'm writing on this right hand side, the bond forming, the bonds which we are forming, nitrogen nitrogen triple bond plus 2 multiplied by hydrogen hydrogen bond. Nitrogen triple bonded with nitrogen is 945 plus hydrogen hydrogen bond energy is 436. So this will be 2 multiplied by 436. So 945 plus 2 multiplied by 436. What's the answer for bond forming? 436 multiplied by 2 plus 945. What's the final answer here? So 4 multiplied by 2 multiplied by 436. So it will be 800 and no, it is 945 plus 2 multiplied by 436. So 2 multiplied by 436, it will be 872 and plus 945. So 945 plus 872. 1870. 1870. That's a bond forming. So bond breaking energy is 1564 plus X, and bond forming energy is 1817. Now the formula is bond breaking energy minus bond forming energy is equals to energy change. So bond breaking minus bond forming is equals to energy change. You can also write delta H is energy change. Bond breaking energy, what is the bond breaking energy? 1564 plus X. That's a bond breaking energy. Minus bond forming energy is 1817 is equals to energy change. What is the energy change for this reaction? It is minus 95. Now it's a mathematical equation which you have to solve. So how you'll solve this? This is minus 1817. So if it is minus, other side it will be plus. And this is plus 1564 So if this is plus, other side it will be minus. So x is equals to minus 95 plus 1817, and this is plus 1564. Other side it will be minus 1564. What is the final answer? What is the final answer when you solve this? 1008 minus 95 plus 1817 minus 1564. Because it is minus here, that's why it is moved to a, yes,
158.
158. So 158, so A is the right answer. Is it clear? So we calculate the bond breaking energy, but the unknown was nitrogen-nitrogen bond. That's why we say this was X. We calculate the bond forming energy. Bond breaking minus bond forming is equals to energy change. And then you have a mathematical equation which you have to solve to calculate the bond energy. Is it clear? Any doubt from question 6 to 10? Question 6 to question 10. Then question 11 to 15, any doubt? Question 13. Heat energy is produced when hydrocarbon burns in air. Which statement represents this? The term hydrocarbon means the compound which contain carbon and hydrogen only. If a compound contains carbon and hydrogen, we call hydrocarbon. But in this first example, you can see this compound contains carbon, hydrogen, and oxygen. So this is not a hydrocarbon. In the second statement, you can see it contains carbon and hydrogen, so it's a hydrocarbon. In the third one, you also see carbon and hydrogen, so it is also a hydrocarbon. So basically a compound which contain carbon and hydrogen are known as hydrocarbon. So in this example, reaction 2 and 3 contain hydrocarbon, that's why D is the correct answer. Is it clear?
Yes.
From question 16 to 20, any doubt? Question 16. A term physical change means if no new substance formed, we call that change as a physical change. Chemical change means in which there is a new substance formed. Physical change means that there is no new substance formed. So melting ice to form water, is it a physical or a chemical change? If you have melt the ice, if there is no new substance formed, the water molecule remains same, only the arrangement changes. So this is a physical change. Burning a hydrogen, but what happened when you burn hydrogen? Hydrogen reacted with oxygen, it will form water. So it form a new substance, hydrogen now changes to or present in water. So it's a chemical change. Adding sodium to water. When you add sodium to water, there is a chemical reaction. Boiling water to form a steam. This is also a physical change because there is no new substance form, only the change in state occur, but no new substance form. So which is the right answer? 1 and 4. So physical changes, no new substance form. Chemical changes, a new substance will form. Is it clear? Question 16. Question 21, 21 to 25, any doubt? In question 18, the energy diagram for this reaction is shown. Reactant have low energy and the product is having high energy. So which reaction is this? This is endothermic reaction. For endothermic reaction, the energy change is always positive. And activation energy for even an endo or exo, it is also positive. So which statement is not correct for this energy diagram? It could be energy level diagram for when a petrol is burned. When you burn petrol, the reaction is exothermic. But this energy diagram is not for exothermic. This is for endothermic reaction. That is why A is not a right or the correct answer. Less energy is released when bond forming. That's true because it's an endothermic reaction. Activation energy is always positive. Energy change is also positive because an endothermic reaction. The only thing, because burning of a petrol is exothermic and this energy diagram is for endothermic, so statement A is not correct. Question 24. A compound hydrogen used as a rocket fuel. It has a structural formula as shown. So N2H4 plus N2 plus 2H2. What is the energy change? So N2H4 structure is given to you. That will be bond breaking. So bond breaking, you are breaking 4 nitrogen and hydrogen bonds. And you are breaking 1 nitrogen-nitrogen bond. What about bond forming? The structure of N2 is nitrogen triple bonded with nitrogen plus H2 means hydrogen, hydrogen. And how many molecules are there? 2 molecules. So bond forming, this is a bond breaking. So if we calculate the bond breaking energy, so this will be 4 multiplied by nitrogen, hydrogen. Nitrogen and hydrogen bond energy is 390 plus nitrogen, nitrogen single bond is 160. What is the answer for bond breaking energy? 390 multiplied by 4. 390 multiplied by 4 plus 160. What is the answer? $1,720. That's a bond breaking energy. Bond forming energy, nitrogen, nitrogen triple bonds. It's 945 plus hydrogen, hydrogen single bond is 436. So this will be multiplied by 2, 436 times 2. 945 plus 2 multiplied by 436. 1817. And to calculate the energy change, the formula is bond breaking minus bond forming is equals to energy change. So bond breaking energy minus bond forming energy will give you energy change. Bond breaking energy is 1720. Bond forming energy is 1817. What is the answer? Minus 97. So minus 97 kilojoule. So B should be the right answer. Is it clear? Is it clear? Question number 24. From question 25 to question 30, any doubt? 25 to 30. Question 29. The activation and the energy change. Basically, what is the energy change? You need this part. If this total energy is minus 342, if this total energy is minus 342, and out of this 342, if this is 342, and out of this 342, activation is 250, how much is the energy change, the difference? We need this difference. So just we need the number. Like example, if I say length of this line, example, if I say length of this line is 342, and out of this 342, from end A to end B, it is 250. So how I can get the energy, the difference of 342 minus 250? That's equal to minus 92. And because this reaction is exothermic, how you identify exothermic? Because reactant have more energy and the product is having less energy. So the energy change should be negative. Minus 92 is a correct answer. Any other doubt from question 31? The 31 is the last one. 30, 31. Any doubt in this? This was exercise 2 of chemical energetics. Any other question you have doubt? In question 17, anhydrous copper sulfate is added to a water, heat is given out. So when we add this copper sulfate to a water, heat is given out. So this water will absorb that heat energy. As the water will absorb heat energy, the temperature of the water will increase. Because the copper sulfate particle, when they mix with water, they release energy and that energy is given out, which is absorbed by the water. So temperature of the water will increase and this reaction is exothermic. If it was an endothermic reaction, the particle absorb energy from the water, so the water temperature will decrease. But in the question they mentioned, heat energy is given out, so the temperature should increase. Is it clear? Any other doubt in this exercise, bonding and structure? This exercise, chemical energetics, exercise 2. Heat is given out and that heat is absorbed by the water molecule. So the moment when copper sulfate dissolve in water or mix with water, the copper sulfate particles are releasing energy. So as they release energy, that energy is absorbed initially by the water. So as the energy initially absorbed by the water temperature will increase. And then the water will lose energy to the surrounding. That's the later part. But the moment when you add copper sulfate and hydrous copper sulfate, the water molecule absorb energy, so the temperature will increase. If it was an endothermic reaction, then what will happen? As the copper sulfate particles absorb energy, so from where they will get energy? They will take energy from the water molecule. So as they take energy from the water molecule, in that case, if it was an endothermic reaction, temperature of the water should decrease, because the water particle loses energy or giving energy to copper sulfate if it was an endothermic. Is it clear? So endothermic reaction, the water temperature decreases. For exothermic, the water temperature will increase. So I'll end the session, if no doubt in this, and share the recording with you. Submit the homework before the class tomorrow, which is about electrolysis. So I'll end the session, share recording with you.